In this section 6, we will be looking at the profit maximization in the long run. Previously, we learned the short run profit maximization problem, which would lead us to the short run unconditional labor demand that is downward sloping, right? When we fix capital. Now that in the long run, when we talk about long run, obviously now both capital and labor inputs must be variable inputs. So we must, our choice variables here would be both L and K. Right? This is gonna be just our variable cost, right? Because K is now variable input. So we set up the profit function just like the short run profit function, but now K is no longer fixed. And we have to choose both L and K. That means that we require two equations for these two unknown choice variables to be solvable. So we get the first order condition, we would take the profit with respect to L and the profit with respect to K, right? And that would be pretty easy. This one is the same condition as in the short run case. And the second one would be just the P times MPK less the rental price or the price of the capital, and it's set it equal to 0. Each of the two FOC says the value of the marginal product has to be equal to the relevant factor price, right? Or marginal benefit of L has to be equal to the marginal cost of labor, as well as the marginal benefit of capital has to be equal to the marginal cost of capital, right? This one is referred to this, and this one is referred to this. So if we divide one first order condition by the other, we will get this, right? That now you can see that it is similar to the tangency condition faced by consumer. So for consumer, we have MUX over MUY. The tangency condition is equal to PX over PY, right? Now, instead we have MPL. So we have MPL over MPK equal to the price of L or the wage over the price of K or the rent, right? So pretty much the same thing. So this is called the left-hand side. This one is just the slope of the isoquant, and the right-hand side is the price ratio, but we're not talking about the cost line yet. So so I cannot really refer to this as the slope of the cost of iso cost. So I'm not going to talk about that yet, but pretty much it is just a tangency condition, right? Where MRTS should be equal to the relative price of the two factors. And I can rearrange this equation, right? Then I get MPL over the bill is equal to MPK over R. Interpretation, the left-hand side means how many output I gain from the last dollar spent on labor. The right-hand side says how many output I gain from the last dollar spent on capital. So if the left-hand side is greater than the right-hand side, that means I should spend my last dollar on L, on labor, or on capital. And the answer is on labor, right? Because the last dollar that I spent on that on labor actually would give me more output than if I spend last dollar on capital. So I would prefer to spend my last dollar on labor. So and then I keep doing that until they are whole equally. The tangency condition says that the marginal product from the last dollar on each factor must be the same. If marginal product from the last dollar on L is strictly bigger than on K, then I can reallocate the last dollar from K to L and vice versa. However, there is no budget line for you to substitute the tangency condition in. So to solve for the optimal LNK, if we have given you the production function and other parameters, you would have to substitute the tangency condition into one of the value marginal product equals to factor price equation. But there is a deeper meaning to this difference, that the firm has no budget constraint. You're not going to limit the total production cost of a firm. Rather, the production cost is also determined in the firm's optimization problem. Okay, so because unlike the budget line we do in the consumer problem, we do not actually specifically impose this condition of the cost, right, on the firm, because remember we just assume that the firm have an access to, to the funding as long as the production is profitable. So we're not doing that. We don't need that. As a good practice, let's check the SOC. Since we have a true variable unconstrained maximization problem, the SOC requires that the Hessian metric. So this Hessian metric is looking like this. So you have a diagonal terms in which this is the second derivatives of profit with respect to L twice, and the second order derivative of profits with respect to K twice. So this of the diagonal is just the cross term. So this one and this one should be exactly the same. And for the SOC, it requires that this metric has to be negative definite. So our Hessian matrix, right? This is second order derivative of profit function. So I can rewrite our profit function, which is total revenue less total cost less the cost to the labor less the cost of capital. So this term would be equal to P times FLL. This term would be P times FKK. And the cross term would be P times FLK, P times FKL. So FKL and FLK are exactly the same. They will equal, okay? And once we have this Hessian metric, for this metric to be negative, definite, we need that the diagonal elements to be strictly negative. So we need these two elements to be strictly negative. And we know that this is the case when we have a diminishing marginal returns, right? Diminishing marginal returns imply that FLL and FKK has to be strictly negative. So that is the one condition. So they need to satisfy both conditions for this Hessian matrix to be negative definite. So to satisfy the second order condition. And first one, these two elements have to be strictly negative, which is true because we have the law of diminishing marginal returns. And the second condition is the determinants of the matrix need to be positive. So you can compute the determinants of this matrix. And the determinants of this matrix would be P squared times FLL times FKK, right? Less P squared times FLK times FKL. So determinants of PFLL, PFLK, PFKL, and PFKK is equal to PFLL times PFKK less PFLK times PFKL. So we take P squared out, we get FLL, FKK less FLK times FKL, right? So this is the determinants of this Hessian matrix, and it needs to be positive. So we know that this is the value of the determinants of this matrix. It needs to be positive. That means that this one is always positive. So this term must be positive, right? For the determinant to be positive. And if you remember this, FLL, FKK less FLK times FKL has to be positive. Remember what this condition is? It's called when the on effect is greater, is bigger than the cross effect. Then this one would be true. Okay. So it follows automatically once we have the assumption that we have law of diminishing marginal returns in both L and K. So that means FLL and FKK has to be strictly negative. And also the on effect is bigger than the cross effect. Then then it follows that our second order condition is satisfied. So the profit, what will we find? We find in for L star and K star, it has to be the ones that maximize, that actually give the maximum value of the profit, not the minimum one. Okay. Diminishing marginal returns, let's just give you this. So this is diminishing marginal returns, and this one is on effect bigger than the cross effect that guaranteed that the SOC satisfied. So going back to our FOC, so this is these two equations. This system of equations, two equations to unknown, specify a relationship of the profit maximizing factors, choices, L and K, given factor prices W and R, and they are known as a long-run unconditional factors demand, right? So if you solve for this, you will get L. So if you solve this system of equations, you will get L star as a function of W, K, oh, sorry, not K, W, R, and P, and also K star as a function of W, R, and P, right? So L as a function of W, this is going to be the demand function, right? When there is a change, how much demand for labor respond to the change in the price of labor. And this would be the demand for capital. How much K changes in response to the change in the price of capital, or R. And this is called long-run unconditional factor demand. Yeah, unconditional because we have not specified a particular output level. So using the SOC, it can be shown that the unconditional factor demands are always downward sloping. So then the W increases, L falls, and when R increases, K falls. To show it mathematically, it requires some metric algebra, so I won't do it here. So just gonna what you just need to know is once you solve this equation, right? Given that the SOC condition that is satisfied due to the law of diminishing marginal returns, and also the on price, on effect is bigger than the cross effect, then we will have the relationship, the inverse relationship for the labor demand, and the inverse relationship for the capital demand, which is just following the typical law of demand, but now this is a demand for input, whereas in the past we were talking about the demand for output. But we're not gonna be showing it here. And what is important though is that those inputs or the factors of production, K and L, that we are talking here, it cannot be a given input or a given factor. And we will be explaining that in detail in the next section.